Hi, I want to take a look at an example of using the kinematic equations when we have a case where we have a constant acceleration for motion in a single direction. And the problem I want to look at is a plane coming in for a landing on the deck of an aircraft carrier. So we're told that our plane is initially traveling forward at 141 miles per hour, and it comes to rest in a span of 2 seconds. So coming to rest means that its final velocity is going to be 0. Now, with kinematics, the key concept that we're dealing with kinematic equations with constant acceleration is there are 5 pieces to the equations of motion, and we only need to identify 3 knowns to be able to solve for those 2 unknowns. And our 5 pieces are our displacement, which is something we want to find because we don't know how far it travels. So our displacement is an unknown. Our initial velocity. Well, our initial velocity is 140 miles per hour. And since this is a physics class, we work in the metric system, we'll need to convert that to meters per second. We have the final velocity, and the final velocity is 0 because stopped is stopped in all units. There's the acceleration of the plane, which we don't know, but we will want to know. So that's our second unknown. And our third known is the time. We're told it takes 2 seconds for that plane to come to rest. So we're going to assume a constant acceleration to make our lives a lot simpler. So when we go to figure out our knowns, or our unknowns rather, from our knowns, it doesn't matter what order we solve in. We could find our displacement first, and then find our acceleration. We could find our acceleration first, and then find our displacement. We could find them both independent of each other, and then check our work by using the value we get for one to calculate the other. That's the nice thing about physics. There's more than one way to do it, and as long as you're following your procedures correctly, you'll get the same answer each way. So, let's start by solving for displacement. So if we want to find displacement, that means we don't need acceleration. So from the 5 families of the kinematic equation, without acceleration, we have the definition of displacement. Our displacement is our average velocity times time. 1/2 times the sum of the initial and final velocities times our time. Now, to calculate that, again, we need to take our velocity and convert it into meters per second from miles per hour. So I'm going to start in the denominator. I need to get rid of hours from the denominator, so when I multiply by my conversion, I have hours in the numerator, seconds go in the bottom. I have 1 hour for every 3,600 seconds. And then to convert miles to meters, miles are getting divided in the denominator, meters go in the numerator, and they're 1,609 meters in every 1 mile. So if I take 140 times 1,609 and divide by 3,600, I get 62.57 meters per second. So to calculate my displacement, 62.57 meters per second plus 0 is still 62.57 meters per second, times 2 seconds cancels out my second units, so I have units of meters. 2 times 1/2 gives me 1. So the plane travels 62.57 meters, which to 2 significant digits will round to 63 meters. Now to find the acceleration, if we don't know our displacement, we can say that our final velocity is our initial velocity plus acceleration times time, which is really just reworked from the definition of acceleration. That acceleration is our change in velocity divided by our change in time. So my change in velocity here is going to be negative 62.57 meters per second. We have a negative acceleration because we're taking away the forward motion of our object. And we change that velocity in 2 seconds. So if I take 62.57 meters per second, divided by 2 seconds, I get 31.3 meters per second squared. So again, to 2 digits, we'll just round that to negative 31 meters per second squared. Now, As an extension, if you wanted to, you could calculate the displacement. Let's start with our final velocity, which is 0. So we'd have minus 1/2 times our acceleration times our time squared. So the minus signs cancel, and that would give me 31 meters per second squared times 1/2 times 2 seconds squared gives me 4 seconds squared times 1/2 is 2. 2 times 31 would give me 62. But remember, this is rounded, this is rounded. That difference between 62 meters and 63 meters is just from working with rounded values rather than working with the full calculated out. If we were to carry out all of the digits that our calculator could give us, we would get the exact same answer using a two-step approach or using just a single step by identifying our two unknowns and using the equation that doesn't use the unknown we don't care about yet. Thanks for watching.